All right, good morning. Welcome back to Intro to Statistics. So we are talking about sampling distributions. This is the end of chapter 7, or chapter 3.7.3 rather. So we have an elevator that's going to accommodate 50 people. And the maximum weight on the elevator is going to hold 9,450 pounds. And according to National Health Statistics Report, U.S. men have an average of 163 pounds and a standard deviation of 63. And so that's the total population. Okay, that's the population average and standard deviation. Okay, notice they did not say anything about normal, is it a normality type of curve or anything like that. So people's weights don't fall like that. Our heights do, but our weights don't tend to fall that way. So we don't know what the underlying distribution is. We don't know what the underlying distribution is for U.S. men. We don't know what the underlying distribution is for U.S. women. That's fine. Okay, so we're going to use a TA84 calculator. If you're using an app for one on your phone for the homework, that's absolutely fine. For a quiz, we're going to have the background checks and all of that stuff, so we're going to need an actual calculator. So if you don't have one, our library does give them out for a few hours. So we could do that, or you get one by other means. But for homework, you don't need to worry about it. So, but for quizzes, you're going to need to do that. Okay, so our sample, okay, we're going to cram 50 people on this elevator. And if their total weight is 9,450 pounds, what is their average weight? Okay, and I'm going to pretty much deal you the same kind of a problem. Okay, so I'm not going out of bounds to wheel. This is a difficult problem by itself. So I'm going to try to make it as close to the kind of thing that you practiced as possible. Okay, so our average weight here is 189 pounds. Okay, so we're just going to write that down over here. We're going to say, X bar is equal to 189. Okay, and that's an important thing to deal with. Okay, so their average weight is 189. All right, check. All right. Now we're going to put a sample of 50 adult men on this elevator. So maybe it's an elevator in a fraternity or something. Okay. What is the probability that the maximum safe weight will be exceeded? Okay, round to 4 decimal places. So we know that X bar has a normal distribution. Why do we know that? Because my sample size, how many people will cram on this elevator? 50. Okay, so X bar has as an average of, we have to go back up to our health statistics reports here, okay? That US men have an average of 163. Okay, I should be so lucky. And our standard deviation here, okay, is 63 pounds. Divided by how many people do we put on this elevator? We put 50 men specifically on this elevator. Okay, so we have a normal distribution because we have n is greater than 50 with an average. This is my X bar. This is my standard deviation divided by the square root of n. Okay, it's my standard error. Okay. And now we're going to figure out, like, well, what's the probability that it's succeeded? So I want to know what's the probability that X bar, that their average weights are over 189. Okay, that's what we have to figure out. So we're going to go to norm, CDF, always CDF. Okay, and we're going to pick what's our low weight. Well, average weight is 189. And then we'll go to, like, my 800-pound life or my 600-pound life and see about that. So pick an outlandishly large number. Okay. So yeah, we'll pick an average of 800 pounds. Okay, so it's an 800-pound life elevator. Okay, I don't think you're getting 50 people on, but that's beside the point. Okay, and then we have to do our average, and our average for total is going to be 163. Okay, because we didn't go around and pick people for my 800-pound life to get on the elevator. We picked 50 people to get on the elevator. Okay, that was a random assortment. So that with their average is going to be 163, and our standard deviation is going to be 63 over the square root of 50. Okay, you could pick any big number here. Okay, the book always does 1 EE99. I don't want to type that in. Okay, that's too much to type in. So pick something that's really big and not worry about it. Okay, so we go to distribution, boom, normal CDF, okay? And we want, well, remember the average weight, the person's average weight getting on this elevator is 189. That's going to be the, how do we make sure it's overloaded? Okay. And for people who are worried about elevators, like they really do put safety factors of like by 1,000 here. They multiply the average by 10 first before they make the elevator. Okay, because they know people. First off, they know Americans put on weight, and then secondly, you never know when you're going to have somebody with a whole bunch of luggage, right? So you don't want to you don't want to be sued for not coming up with a good elevator plan. Okay, nobody will hire your firm again. It's not good. Okay, so CDF 189 is bigger than 189 up to the sky's the limit. Average was the average of the population, not of the sample. The sample's 189. The population, 163. And then we're going to have a standard deviation for that population. And we'll hit enter. 0.0017, 0.0018. Okay, so almost a 2%, no, a 0.2% chance of overloading the elevator. Okay. There's probably some kind of a national safety something that does something for that. Okay. I will say 1.8 for rounding it off to 4 decimal places. Okay. 1, 2, 3, 4. We'll change that 7 into an 8. Go ahead and check. Hey, what do you know? Part B is we're going to put this elevator in a sorority and figure out that. Okay, so 2 problems for the price of 1. So we're going to take a sample of 50 adult women to ride the elevator. We're going to do the same thing. Okay, so we're going to figure out what's the probability that X bar is greater than. It still has to be 189. That's the first number we calculated, right? That was the first number we calculated for this problem. X bar has to be above 189. Okay, the fact that we have a different distribution now because this X bar, because it's women, not men, we are going to have a different average, okay, and a different standard deviation. Okay, so we're going to go back up here. We're going to say, okay, well, women have an average of 159 pounds. And again, this is not a normal distribution. I don't know what shape of distribution this is, okay, but it is not normal, okay. And then 72 divided by the square root of 50, because that's how many people we're putting on this elevator. Okay. So we're going to get our probability for that. So it's going to be norm, okay, CDF, okay. And again, we want 189, sky's the limit, okay. Go with the scariest show on TV, 800 pounds. Okay. And again, we're not, selecting a whole bunch of people that weigh 800 pounds to put on this elevator. That would not be a good thing to do. Okay, but our overall average, right? If I just grabbed 50 women out of a crowd, I would just said, okay, 159. That's the average weight, according to this statistic here. Okay, and the standard deviation, 72 over square root of 50. Okay, and we're going to calculate that. It's going to be a small number. Okay, so we're going to do second function distribution, norm CDF. All right, and we'll say 189, comma, 800, 159, and then 72 divided by the square root of 50. Okay, and then we'll go with that. Okay, 0.0016, 0.0016. Since it goes to 4 decimal places, we'll stop at that point. Okay, so that'll be 0.0016, right? So we'll go back down here. So it's a little bit smaller for women. I wouldn't say by a whole lot, 0.0016. Okay, and so 2.2% if you squint at it. Okay, so we'll go ahead and check, get the green flag, hooray, and we'll go on to the next one. So definitely expect one like, okay, when I put this quiz together, expect one like 9 or 10. Okay, so either the elevator problem or the roller coaster problem. Okay, so we're definitely going to be looking at, I'm sorry, 8 or 9, not 8 or 9. Okay, expect one like 8 or 9. Be able to do this. Please practice them. Okay, unfortunately, this book has all of 2 problems like this, so I'm just going to pick one of these to do this. Hopefully, it'll randomize it a little bit for us, but you could expect one of these. You could expect a problem like number 4 too, but you should expect a problem with 8 or 9. So please practice. Make sure you could do one like this, and I'll see you in the next video. Thank you.